Good afternoon, sir.
Good afternoon. Okay, so let's start theory part. Then attendance I will take later. Are you able to see the screen?
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
Yes, sir.
okay,
Yes,
okay.
sir.
Good. So don't share any part of the study material to any social media platform. Slides are prepared from the following books: Engineering Mechanics Statics, Volume 1 by Merriam and Craig. So today we are going to start new chapters, area moment of inertia. Moment of inertia, it could have two parts. One is mass moment of inertia, and second one is area moment of inertia. So this you have studied in 10 plus 2 standard, and this is new. In this statics part, we will define or discuss new chapters, that is area moment of inertia, that is not mass moment of inertia. So you might be knowing this: for area moment of inertia and mass moment of inertia, what is the expression was r square dm, is not it? This way you have learned, no? Mass moment of inertia, something like this.
Yes, sir.
Okay. Here we will replace this m by area, dA. We will use dA. So mass will be replaced by area. Mass will be replaced by area. So in this mechanics subject, when we are dealing with dynamics, we use mass moment of inertia. But some of the statics problem will use area moment of inertia. And intentionally never will use mass moment of inertia even for dynamics also. So this mass moment of inertia is not applicable for your mechanics subject. It will be area moment of inertia. Somebody in solving problem in exam, if I found that they have used these expressions, mass moment of inertia, so I'll cut and I'll give 0 out of 10. It will save my time. So what I am looking for, area moment of inertia. So first of all, say one elemental area dA, elemental area dA. If you take one moment, then it is RDA, we called first moment. Even if you use another moment, another times moment, we call moment of a moment or second moment of area. This is first moment of area. Here it is second moment of area. Why it is important? What is the physical significance? Why we will be using this? This is purely mathematical term, expression, mathematical expression. So there is no such physical significance of this, but this type of area moment of inertia, second moment of area will be required for few cases. Those things are important. Say for example, I have one bar and maybe this is the cross sections. If you say an area is A, if you apply some force P, okay, then this P by area, say measurement of the stress, and if it is elongate like this, some deflection delta equal to PL by AE, delta equal to PL by AE. So we need only A value, that is okay. Whether A is like this, same A, say one is like this, value is same, say 100 millimeter square. This is also 100 millimeter square, shape are different. Or maybe this, same value. Or maybe this, circular cross sections, square, rectangle, or maybe hollow one. Same area. Then deflection for tensile load, it will be same. It does not matter what is the shape. If area is same, so I can divide this way. One is shape, other is size. Size will give the value, say millimeter square. How much? Say 100. Size and shape are different. One is rectangular, other is a circular, hollow circular, cross sections. Okay, we are talking about cross section. CS is cross section. Then square. Maybe I can consider one triangular shape also. Triangular. Axial tensile load, axial deformation same. Now, let's consider another case. I can erase here itself. Say this type of loading P, we call bending load. It will bend like this. And this deflection is this side. Okay, delta. Now cross section, you assume this is the cross sections. A. You consider this is the scale. Everybody you have used scale, correct? Now maybe this is the scale, one end fixed, other end you have applied some transverse load. We call bending. It will undergo bending. Now there are two cases, same cross sections. Case 1, case 2. Do you think displacement will be same for case 1 and 2? You consider one scale fixed in using one hand, other hand the tip you apply some transverse load. Two configuration we can consider this way and this way. Do you think the deflection will be same or it will be different?
Sir, axial deformation will be same.
No, no, I am taking this deformation is vertical only, okay? Vertical only,
No, sir. This will be different.
different. So which case it will be more displacement? One or two?
Two. Second.
Second one.
One.
That means second one. See here what we understood delta equal to inversely proportional to A for axial load. But for bending load, it is A is same. Okay. So all this case A is same, but deflection are different. Actually, in for this case, this deflection will be proportional to 1 by some other term we called I. This I is area moment of inertia. New term I is area moment of inertia, and we'll show that I for case 2 is less. That's why deflection will be more. So here both shape and size are important, but for axial case only size was important for us. So all the cases, a cross-sectional area was same, so axial deformation was same. But for bending case, for different cross sections, I value will be different, and hence deflection will be different. Higher I value will give less deflection. Lower I value will give higher deflection. This is one type of problem. Another type of problem, say this is one circular area, one bar, and we have fixed it. And I have applied some torque here along the axis. So if you see the cross sections and divide this into 4 parts, so initially one point was like this. Now due to this application of torque, this point will move here. So this is point A, this will be A prime. There will be some theta angle, we call twist, angle of twist. And this angle of twist we represent by say theta. Theta will be proportional to 1 by some other term. Okay. That term is say J. This area moment of inertia, it was rectangular basically. I will explain everything later. Rectangular. Because we have considered this axis, rectangular axis here, rectangular axis. This is X and say this is Y. This is X and say this is Y. But here it is axis or Z axis basically. Okay. Somebody write IZ. It's fine. If you write this IX, then this one you write IZ. I'll show you. Somebody can write this IZ polar moment of inertia. And sometimes it is been denoted by J. So what I want to say, for axial member, cross section A is enough, and different size of shape of cross section, size is same, then deflection will be same. For bending case, it is depending upon not area, it is depending upon rectangular moment of inertia. For torque problem, it is polar moment of inertia, inversely proportional. Now, this is for your understanding why we will use this moment of inertia in static problem. We are not dealing with dynamic problem. And that cross section A will be replaced by moment of inertia, area moment of inertia. Sorry, for those cases. Now I'll go into little bit. This is the practical examples I am giving. Derivation I cannot show. It will be for students like computer science, IT, electronics, electrical. All these four department will not go for the higher studies for coming semester in details for that, but for others like aerospace, civil, mechanical engineering, metallurgy and mining, they will come to know this one later on, and application wise, stress wise, deflection wise. So, but this is the nutshell of the requirement of the area moment of inertia. I will explain in other way also. Just 1 minute. Say this is one pond and this is some dam. This is a dam, or maybe we want to calculate the pressure along the depth. Say one particular case, particular height. This is the area. As all of you know, the pressure will be like this, compressive, and people write this pressure expressions. Pressure equal to rho g and height. Here rho g, height is y, and rho g we called this as specific weight. 10 plus 2 standard idea, specific weight. Okay, and maybe you replace by say K1 y. K1 is the specific weight. Here I am writing K1 P, pressure equal to K1 y. Here pressure P equal to K1 y. Actually the pressure is varying with the distance from the top of the say fluid or water. Now if somebody want to calculate force and elemental area, say dA, so force will be K1 y. This force basically elemental force on that element, small strip, area is dA. So force will be this pressure multiplied by dA. What is the elemental moment of that element? That moment will be K1 y multiplied by dA multiplied by y. Now total moment of vertical, let me consider this vertical, this is one wall of a slice gate or something, okay, of vertical wall. Total moment, that will be integrations Q1 y square dA. Q1 is constant, we can keep it here because rho is constant, g is constant, is assumptions. So this is y square dA. That indicates it is the area multiplied by 2 times distance. That means y dA first moment multiplied by y square dA. Then it is coming for integration to calculate the total value of the moment. That means there are some cases where the moment expression will give 2 times distance multiplied by elemental area, integration of that. This is bending problem. You know just this one. In this case, it says that there will be some plane we call neutral axis or neutral plane. So bending stress will be 0. Then bending stress will vary linearly with some constant, say sigma equal to K2y. Some constant here, K2. I am giving instead of K2 because K1 I have given here. So that is 0 here and it is linearly varying like this with the distance. Here also it is varying with the distance. So if sigma equal to K2y, then force will be K2y dA. That will be elemental force. So moment, for this case that moment will be K2y square dA. Total moment will be integration K2y square dA. Here also we can see the something expression like distance square dA and integration about that. When it is torsion case, then this shear stress is 0 actually here, then it is varying linearly. Shear stress is 0, with that I will show you this way. Shear stress variation was like this. This was 0 at the center. And shear stress is varying 0 to some value like this. This is the variation of the shear stress. Tau, shear stress tau, sigma is the normal stress, tau is the shear stress. Some K3 multiplied by distance R. If this is the shear stress, then force will be K3 R delta A. That is the force. Moment will be K3 R square, sorry, dA. Total moment will be integration of that. Or I will do here K3 R square dA. That indicates based on the specific application, apart from this simply some load in axial load, you have applied some axial force. There are some cases like pressure variations, some cases bending stress variation, some cases torsional shear stress variations, where the stresses, sigma is the stress, pressure also that unit is say Newton per millimeter square, that is varying with some distance. That is varying with some distance. That means y, some constant k1 or k2 or k3 or k multiplied by y. Then first moment, then force will be multiplied by dA. First moment will be or moment will be multiplied by the distance. Then you will get distance square dA and over the integrations. That is the way moment of first of all it is area, moment of area, then moment of area, second moment of area. That concept has come as per, from the application point of view. Now this moment of area is known as second moment of area or moment of inertia. Area moment of inertia. From that we got this word, not mass, okay? Area, not mass. Area moment of inertia. Or we call second moment of area. That concept has come from the application point of view. Is it clear up to this?
Yes, sir.
Yes, very good. Next, so what we understood that some stress, it is some k multiplied by y, then we will take moment and finally we will get these expressions. This is one case. Then for shear stress torsional case, we got kr square dA. This is second case. Now, from that concept, we call moment of inertia, second moment of area. Now this word inertia appears to this terminology to make it similarity between like that mass moment of inertia. Here it is similar expression. It is r square y square dA. It was y square dm. To give the similar terminology, we have used this area moment of inertia. That word inertia word we have used, but 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 it is purely mathematical property, and itself has no physical significance. It does not have any physical significance. We have compared with second moment of area, okay, and results moments, so called inertia force for the rotating bodies. That means mass moment of inertia r square dm. Here it is area moment of inertia, say r square dA. This inertia has been kept same. Otherwise, this is purely mathematical expression. There is no physical significance. Don't be confused with mass moment of inertia and area moment of inertia. This will not be considered or will not be covered in this mechanics subject, even neither in the dynamics. We have excluded that portion. If somebody look here, this is length square, it is area. That is also length square. Basically, this unit is length power 4, whereas this was kg, say meter square. Mass moment of inertia was something like kg meter square, kg millimeter square, like that. Now here it is L power 4. L power 4. So millimeter power 4, then meter power 4, inch power 4, and so on. Now we have two ways we can give this moment of inertia. One is we call a rectangular moment of inertia, polar moment of inertia. Rectangular is related to xy Cartesian coordinate. Polar moment of inertia related to r theta, polar coordinate. Now when we are considering the rectangular moment of inertia, let me consider this small strip dA, distance from x-axis and y-axis. This is the 0, 0 point. Distance are y and x. Y and x. And maybe this from this to this, the distance is r. Okay, try to understand. We have x, y, Cartesian coordinate, another is r theta. Basically, we call r theta z, both r theta and z, all three. In xy coordinate, this is the y, this is x, and this is the r theta. What is z? Z basically perpendicular to this plane. So if it is x, if this is y, then z is perpendicular to this plane. We never use that term like this z, but it is perpendicular to the plane. Now, by definition, we can consider that for these elements, there are two elemental rectangular moment of inertia, Ix, we will write Dix. That will be, if you want to calculate your moment of inertia with respect to x, then what is the distance you have? Y. This is the distance y. Then we will use y square dA. When we want to write this diy with respect to y-axis, then distance is x. So we will write x square dA. Very important for this. Dix equal to y square dA, because the distance is y. Diy equal to x square dA, because distance is x. And total value, if this is the elemental case, Ix will be y square dA integration. Iy will be integration x square dA. Now, if somebody want to calculate something with respect to z axis, this z axis. Say I can write this is IZ. This is IZ equal to r square dA. Because with respect to z axis, this is r radius, r square dA. On the other hand, somebody can write x square plus y square equal to r square. Or if I write y square plus x square, same thing, correct? So I'll write this way, y square dA plus integration x square dA. This is nothing but Ix, this is nothing but Iy. So somebody can write this Iz equal to Ix plus Iy. Just mathematical expression. Once again I want to say, in Cartesian coordinate I have x and y coordinate. Elemental area dA, distance from x axis is y, from y axis it is x. And from 0 point O, distance is r. R square equal to x square plus y square. This r basically the distance of the right angular triangle. Now by different definition, when I want to calculate area moment of inertia with respect to x axis, I'll write y square dA. For elemental case, dix equal to y square dA, ix equal to integration of y square dA. Similar way, when I want to calculate rectangular moment of inertia with respect to y axis, Iy equal to integration of x square dA. Somebody want to calculate that this moment of inertia with respect to z axis, Iz, that is r square dA. As r square equal to x square plus y square, somebody can write Iz equal to r square dA equal to integration of y square dA plus integration of x square dA, that is Ix plus Iy. Some books write this as a J, polar moment of inertia, that is Ix plus Iy. So this is the Iz with respect to z axis, that is Ix plus Iy, or somebody write J. Okay. So Ix Iy is rectangular moment of inertia and J is polar moment of inertia, because z axis, somebody can have, as I told, x, y, this is the z axis and this distance was r. Obviously it is involved with some theta you can consider. So r theta z. Okay. Now we understood that yes, we can have some elemental area and we can write Ix equal to some expression, Iy equal to some expression, Iz or J equal to some expression. Fine. Now, as this is the total area, actually, how this area are being distributed from the any axis, either x axis, y axis or z axis, to represent that, how this area has been distributed. This idea is, say somebody want to say this total area is been distributed like some small strip that is parallel to the x-axis. Same area, very small strip. Area I want to redistribute it using very small strip. Or maybe somebody want to consider that, let it be this area may be distributed in a vertical axis in a very small strip like this. Or somebody may want to say, this area can be distributed in a circular path like this. I'll write this way. Some very thin area it is distributed with some radius. Same area. This is the x and this is the y and this is the z. So if you distribute like this, for say this way, respect to polar axis, polar coordinate, and you want to distribute this along very small strip, same area with some distance, say kx from the x-axis, same area, or maybe same area in vertical directions, very small strip thickness is very thin and very it is elongated along this vertical axis, and distance say ky, and this is say ry or kz, let it be kz. Then this kx, ky, kz, these are called radius of gyrations. These are called radius of gyrations. So this is the total area initially. Say this is the area I want to calculate, such that imagine that it is perpendicular parallel to the x-axis and it is cut out. It is infinitely long. Area is same and distance is kx. Here it is ky. Here it is kz. If it is so, it is our imagination. We want to calculate the way this area has been distributed from the axis. If we can assume that these are the equivalent, so this is very small strip, then Ix will be here, this k square dA. Sorry, total is A. This Ix will be k square A. Here Iy will be ky square A. Here Iz will be kz square A. If I equate this, initially what we have here at the beginning, whatever we have considered, now we are considering that let it be very thin strip, either parallel to x-axis, parallel to y-axis, parallel to z-axis. Then from this we can write this expression kx equal to square root Ix by A, ky equal to square root, somebody call this kappa also, okay. I am writing just small letter k, don't worry. This is Iy by I, this is Az equal to square root Iz by A. See, this is length power 4, length square. So as a whole length square root, it will be length. Yes, that means radius of gyration is the measurement of the some length. Okay. So what does it represent? The radius of gyration is a measure of the distribution of the area from the axis given in the questions. It may be rectangular moment of inertia, it may be polar moment of inertia, we have already told. Now as we know, this Iz equal to Ix plus Iy, that means this kz square A equal to kx square A plus ky square A. If I cancel out k, it is kz square equal to kx square plus ky square. This is the expression or relationship of the radius of gyrations of the polar with respect to polar coordinate. You can have relationship with the rectangular coordinate. So what we will learn from the beginning, Ix, Iy, Iz, then Kx, Ky, Kz, Iz equal to Kx plus Ky, and here Kz square equal to Kx square plus Ky square. Kx equal to square root Ix by A, Ky is square root Iy by A, Kz is square root Iz by A. Now, here we have the provisions to transfer the axis, but those axes supposed to be parallel to the either x-axis or parallel to the z-axis or maybe parallel to the y-axis. So we call transfer of axis provided we are using some parallel axis with the centroidal axis. I'll tell you. Initially I have centroid is C, and this is y0 and this is the x0 and y0. This is centroid. Centroid is located here. What is the definition of centroid? If it is centroid, then your yda equal to 0 and xda equal to 0. Here it is distance is y0 for this element and x0 for x0 and y0. So right, if this is the case, then it is this y0 arbitrary y0 x0 means this 0 this 0. This is the definition of the centroid. Definition of the centroid is integration y dA or x dA with respect to the centroid itself, the value will be 0. Okay. From where we got this? Because we used to write this is y dA integration over dA. dA cannot be 0. This integration cannot be 0, so this is supposed to be 0. This is the 0 for the centroid. So y bar equal to, just a minute, this is x basically, okay. This is y dA integration over dA. So this will be 0. That means x integration x dA 0, integration y dA 0 for the definition of the centroid. Now if we consider the distance in terms of y0 and x0, then this will be the 0 definition of, this is the definition of centroid. We will utilize that chapter concept centroid, definition of centroid. Okay. Now initially we have C point and x0, y0 at the axis. We are considering some element dA, elemental area dA, distances from x, the distances are x0, y0. That is the coordinate of the dA. Okay. Now we consider we want to transfer this with some other axis with respect to this 0. This is xy axis. And this OX is parallel to the CX0. Okay. And this OY is parallel to CY0. That's why we call transfer of axis parallel axis. We should write transfer of axis with the parallel axis. And let's have some distance dx from the x-axis for this coordinate, and for this coordinate it is dy. Distance is dy. So dx and dy. Now we'll use the theory which we have discussed to calculate this parallel axis for the concept of Ix and Iy. Now somebody can easily write from the previous discussion that yes, dix with respect to this basically, that is by definition distance of this square. What is the distance now? Total distance y0 plus dx.
Gx plus y0.
Yes, y0 plus dx square dA. That is our definitions. This is the dix. So ix will be integration of y0 plus dx square dA. Okay. Now this is, if I split it, y0 integration y0 dA plus 2 dx is constant, is not it? Because this distance you have this distance offset you have considered, this is constant. This dy is also constant because you are considering for particular case. So dx0, then it is y0 dA plus dx square dA. I miss here square, okay, but already we know this is nothing but Ix. This is nothing but Ix0, or somebody can write this like this also, Ix bar. Ix bar is based on the centroid. Either you can write Ix0 or Ix bar. No issue. Your understanding is okay. It is based on the centroid. Plus, this is this integration and this value YDA. By definitions, this will be 0 for the centroid. This will be 0 for the centroid. So this will be 0. And this is just constant and dA integration will be A. So it will be then A dx square. I will write this once again. Ix equal to Ix bar plus A dx square. Simply, it is the value of the centroid plus total area multiplied by the distance squared. Which distance? The distance between centroid of the body of the object or cross section to the which axis you want to consider. Somebody can work similar way. Iy will be Iy bar plus A dy square. Iy equal to Iy bar plus A dy square. Somebody can write similarly Iz equal to Iz bar plus A d square. This is the d. Iz equal to this plus Iz equal to Iz bar plus A d square. If it is so, you can write this way. If it is so, then we know this Iz is k square. We should, in terms of radius directions, this k square A equal to A square Z, I should write here. A equal to k bar square at the centroid A plus here it is A d square or kz square equal to kz bar square plus d square. That are the relationship between the radius of gyrations. Somebody can easily show. So this theory says that whenever you have one centroid and you know that Ix and Iy with respect to the centroid, somebody can transfer the axis from the centroid provided new axis, x-axis is parallel to the previous centroidal axis, new y-axis should be parallel to the previously centroidal axis. Then relationship is something Ix equal to Ix at the centroid plus A multiplied by distance square. Here it is dx square. For Iy, it is Iy equal to Iy bar plus A dy square. Iz equal to Iz bar plus A d square. Or in terms of radius of gyration, kz square equal to kz bar square plus d square. This is called parallel axis theorem. This is valid only between two points. Between two axes, one axis must pass through the centroid. I should write this word carefully. Link in color. Valid between two axes provided one is passing through two axes or between two parallel axes provided one is passing through centroid. Because this expression, this has to be satisfied. Otherwise, this will not be valid. So you cannot say, for example, I have one circle. I have calculated based on this axis some rectangular moment of inertia. I have to calculate rectangular moment of inertia with respect to say this axis. So this is AA, this is BB. I know some IA value, some value no. I have to calculate with respect to BB. I cannot jump from A to B. What I have to do? From this to I have to move here. Say it is CC, centroid. Between this AA and CC it is valid. Then between CC to BB it is valid. I cannot jump from AA to BB. Okay, because these two axes, parallel axis, out of these two, one supposed to pass to the centroid. So I cannot use that theory. That theory is valid between two parallel axes, provided one is passing through the centroid of the body. Is it clear up to this?
Yes, sir.
Yeah, fine. So that one I have shown here, that for elemental case dix equal to this square plus dn. I want to expand this. First term, second term, third term. Okay, dx was constant. So this is nothing but centroidal ixx. This will be 0. This will be 0 from the definition of the centroid. Definition of the centroid. And this is dA integration will be A. So this relationship, then from the IZ, this is the relationship. This is the parallel axis theorem. Okay, 2 points should be noted. First, the axis between which the transfer is made must be parallel. Second, one of the axes must pass through the centroid of the area. Two things, those between two axes must be parallel, and second one is one of the axes must pass through the centroid of the area. Why? Need to be satisfied. This need to be satisfied. To satisfied as 0. If this is 0, then only this is valid. Okay, you have to be careful for that. Then we have shown that radius of gyration, this relationship also. Now let's have some examples. Like it has been asked that determine the moment of inertia of the rectangular area. This is one term, moment of inertia of the rectangular area. So here it is area. As a whole, it is area moment of inertia, not mass moment of inertia. So unit will be L power 4. About the centroidal axis x0, y0. The centroidal polar axis z0, z0 through C. So this is the C centroidal area. This is the x0. This is the y0. You have to calculate area moment of inertia with x0, y0 and z0. As I told, z is perpendicular, polar one. Then also with respect to x-axis, then polar axis z through O. Polar axis z through O. Try to understand. First of all, we will calculate Ix bar, Iy bar, then Iz bar. All three are at the centroid. Then we will calculate Ix at the base. Then we will calculate Iz with respect to O. So to start with, first of all, we will simply use this expression Ix equal to y square dA. So this is the elemental area. dA is dA equal to B dy. This for this element, area is B dy. Then y square B dy. So this is Ix bar. This is y square dA, y square B dy. So B y square dy. Okay. So y square B dy, B is constant, y square dy. Y square dy integration means B y cube by 3. What is that integration limit? Minus h by 2 to h by 2. Minus h by 2 to h by 2. Somebody can put and you can get 1 by 12 b h cube. 1 by 12 b h cube. So 1 by 12 b h cube. I'll tell you. Say this is the case. This is the case. Okay. Now, if I interchange this, if I make this interchange b and h, so it will be looking like this. It will be 1 by 12 h b cube. Height, this is the h and this is the b. Now, if you compare the ratio between these two, this is h. Okay, take the ratio. So it will be cancelled out. Then this will be h square. This will be h by b square. H by b square. So this h value is high, then the b. That's why when you have told that I value, if you compare between this, so I1 and I2, or maybe I1 and I2, say for example, then for the problems I told at the beginning, let me check. Yes, this case, you consider this 1 by 12 b, this is the b, h cube, and this one is 1 by 12 h b cube. You see this b is small, h is high. Here, that's why this one is much higher than this. This I is much higher than this. If it is so, then deflection is inversely proportional to I. So definitely the deflection for case 1 will be less. Deflection of the case 2 will be more. Now you come to this all exercise. Same cross sections, different value of I, same cross sections, but different, your size is same, millimeter square is 100 millimeter square. But shape is different. One is rectangular, other is a hollow, circular, different. Then I value will be different. Once you have the I value different, similar way, you can have J value also different, J equal to Ix plus Iy for torsion problem. That means based on even same shape, sorry, same size, cross section, shape are different. That will give more value of I and J. More value of I and J. That will give, target is higher value of I, higher value of J, to give more resistance against bending, to give more resistance against torsions. That's why you have seen many times hollow shaft we are being used. Shaft are being hollow. Okay, hollow shaft we have used. Okay. Then also we'll see different cases. You have seen that structures are this L shape, angle shape. This is the angle shape because this is having higher value of resistance compared with only simple this. Sorry, compared with this simple this cross section. This is better. Sometimes you have seen I sections. Sometimes you have seen this I sections for many of the engineering components. Sometimes you have seen the Z sections. In aerospace, many times you have seen the Z sections. Sometimes you will see the C sections. These are the C sections. Sometimes people can see this hat sections. This is called hat sections. Why? Different sections are available because if you are using different sections, cross sections, that will give different value of I or J, that will give more resistance against bending or against torsions. Here once again we will back to the problems. Now we understood that this Ix bar equal to 1 by 12 base 1 by 12 multiplied by base multiplied by height cube. For IYY also same thing, 1 by 12. Here base is h. For this y axis, base is h multiplied by y cube, multiplied by height cube. 1 by 12 multiplied by b multiplied by base multiplied by height cube. You will get this value. Then what is that? Polar moment of inertia with respect to the centroid? Iz bar equal to Ixs plus Iyy. You put this value and you will get the final expressions. Now, using parallel axis theorem with respect to x-axis, parallel axis theory with respect to x-axis, then that Ix will be Ix bar plus A multiplied by distance square, dx square, and that dx is h by 2. So that will be 1 by 12 bh cube multiplied by distance area b B multiplied by A, this is the total area, B multiplied by H, then distance square. Then you will get the value. Last one, it has been asked, considering it through the polar axis Z through O here. If you use O, then what you can draw? This distance R. This R basically, this R, if it is R, then R square will be B by 2 whole square plus H by 2 square. That is the R square. And this is the centroid. This is the centroid. So here value will be Iz will be Iz bar plus AD square. Iz already you know, this is the Iz. A is this area, B multiplied by H, and then R square. This R square equal to this and this. Then you, whatever value you will get, you can calculate. One thing you have to calculate, understand this Ix equal to, if I write this way, ICG x plus area multiplied by distance square. Simplifying this. That shows area cannot be negative and distance maybe x-axis, y-axis, positive, negative, but finally it is square. Then definitely this Ix will be greater than IXCG. That means I value at the CG is lower value compared with when you are using some parallel axis theorem. That is true for IY, that is true for IZ also. For the centroid, it is comparatively lower value when you want to using the transfer using the parallel axis theorem. Now, so we have these examples. What I want to say, when it is we are considering at the centroid, value is comparatively lower. When it is at the base, values are comparatively higher value, and it will follow parallel axis theorem. But you can recall that for this, with respect to centroid, 1 by 12 b base multiplied by height cube, but with respect to this base, it is 1/3 multiplied by base multiplied by height cube. So if you have this case, 1 by 12 multiplied by base multiplied by height cube, with respect to this base, it is 1/3, it is 1 by 12 base multiplied by height cube. Now you consider that let's we have one triangle cross section. We have to calculate with respect to base and about the parallel axis theorem through the centroid and the vertex. So first of all, this base, what we will do to calculate this? Simply we will use this expression Ix equal to y square dA. This is the y. What is dA? dA is here, it is x dy. dA is x dy, but this Ix equal to y square x dy, all are with in terms of y, x is something different. What I want x, we can put in terms of function of y. So what we can do from the similarity triangle, we can write b by x, base b by x equal to, this is the height, b by x equal to this height by height minus y.
X minus y.
Yeah. X equal to b by h minus y. Is not it? Yes.
Yes, sir.
So this x equal to, just a minute, this is b. Yeah. So then we'll write Ix equal to y square b by h minus y dy. B and h are constant. Okay. So what we can do, let it be b by h, then h y square minus h cube dy. We can write this way. Sorry. Then integration in terms of y 0 to h, 0 to h. Okay. You can do this integration. Finally, you will get this. 1 by 12 multiplied by base multiplied by height cube. You have to be careful. When it is triangle, when we have rectangle this way, then 1 by 12 bh cube. But when it is triangle with respect to base, that is also 1 by 12 multiplied by base multiplied by height cube. But for this case, it was 1/3. It is 1 by 12. For triangle with base, it is 1 by 12. Okay. Now, next it has been asked you have to calculate through the centroid using parallel axis theorem. So, parallel axis theorem, moment of inertia at the centroid will be lower value, is not it? That will be lower value than the axis when we are some away, say x axis. So, I used to write this way, Ix equal to IXCG plus A d square. Ix means this Ix higher value equal to IXCG, this is centroid plus A d square. This d is, sorry, this d is 1/3 h. We already have shown, no, this will be the CG locations. So from this base, the distance will be 1/3 of h from the base. So IXCG will be Ix minus this. IXCG will be, it is better write this way. IXCG will be I minus this. You put the value, you will be getting this value. Somebody can write here this way also, unit power 4. It looks better. Okay. We don't know the unit. It is unit power 4. Okay. Now it has been asked then, what will be the value at the vertex? Vertex is this x prime. So for the vertex, okay, I will be ICG plus AD square. Okay, ICG already we have calculated, BH cube by 13, 6 plus B plus AD square. A is area, half of P multiplied by A, similar. Here the distance is 2h by 3, that square. Then you will get the value. You have to be careful. When we have utilized this parallel axis theorem, axes are parallel. Second one, out of two axes, one is passing through the centroid. Nobody can work like, say for example, I told calculate the Ixx value with respect to base. With respect to x-axis, then move to x prime axis. I told this, then this. I am not told the calculate based on the centroid. I am not told. I told say this and this. You cannot jump from this to this. You have to come from this base to the centroid. Okay, because out of this one is at the centroid. Then you get at the centroidal locations. Parallel axis theorem will give you IXCG. Then you convert or move from this point to this vertex, IXCG plus A multiplied by D square. Now which D will be for the centroid locations, which A you can calculate easily. I am not going into detail that one. Okay. Now, say but another example, the calculate the moment of inertia of area. Moment of inertia of area means area moment of inertia of the circle about the diametral axis. If it is been asked about the diametral axis, it is basically perpendicular to this plane, z axis. And okay, so calculate the moment of inertia of the area of a circle about a diametral axis and about the polar axis through the center. Oh, both it is been asked. So this is the diameter, this is the axis. It is told this is two axes, x and y, and and polar axis, three axes basically. X, square. I'll tell you. So what we'll do, I'll write Ix equal to y square dA. Ix with respect to x axis. So Ix equal to y square dA. What is the y? Distance. If this is r0, the distance is r0 sine theta. For Ix. For Iy, it will be r0 cosine theta. So r0 sine theta square. This is the square. Multiplied by dr0, r0 dr. See, r0, sorry, last one was s equal to r theta. That expression will be, ds will be, here ds will be r0 d theta. Yeah, it is d theta. Okay. So this r0, dr0 d theta. Second integrations, theta is varying from 0 to 2 pi, r is varying from 0 to r. You do the calculation correctly, same value will get. Ix will be pi r power 4 by 4 or pi d diameter d power 4 by 64. Now, people can enjoy with this that instead of one solid circular solid cross section, somebody can have instead of d like some hollow cross section people can use the hollow pipe. So it's a d outer square then d inner square by 4 64 say pi. And you might be having same cross section. So one is solid cross section, one is hollow. Hollow one will give higher value of j value or iz value or ix or iy, more resistance. That's why many times we have seen to utilize the hollow shaft to, first of all, to reduce the self weight. Second one, to give more resistance against the torsions or maybe against the bending. So when it is axial member, cross sectional area, that that size is important. But when it is bending or torsion, both size and shape. Shape means Z section, I sections, L section, C sections. Many times in aircraft component you can have different cross sections. In many cases, in civil structures you can see the channel sections. In many cases, in metallurgy mining you can have L shapes cross sections. Just a minute. You can have L shaped cross sections. Just a minute. Okay. So we are here. Yes. So our idea will be to utilize this concept, polar moment of inertia, rectangular moment of inertia, to give more resistance to the structure with the expense of less materials, material cost, and mainly to get higher value of factor of safety. Okay. Now it is been asked that determine the moment of inertia of the area under the parabola about the x-axis. You can solve using horizontal strip. You can solve using the vertical strip. So this is the curve given parabola x equal to ky square. It is passing through this point. This point. See, this is 3, 4. Sorry, 4, 3. Okay. So you write 4 equal to k 3 square. So k equal to 4 by 9. That means this k value is indirectly given 4 by 9. So x equal to 4y square by 9. Let me take horizontal strip. You take horizontal strip. What will be dA? What will be dA? Area. It will be height is dy multiplied by this distance. I guess this is 4. This is 4 and this is x. So it is 4 minus x. This length is 4 minus x multiplied by dy. So what is x then? So 4 minus 4 by 9 x will write y square dy. This is the dA. Then ix will be dix will be y square dA, and we will do the integrations. You can see here. So we got first k value, then dA will be this 4 minus x dy, then this is these things y square dA. You put this value, integrations y is varying 0 to 3. Yes, 0 to 3 you will get this value. See, it is unit per 4. Unit per 4. Horizontal strip we have taken. Now we can take vertical strip also. For this vertical strip, dix is 1/3 multiplied by base multiplied by height cube. I can directly use this elemental concept. 1/3 of base dx multiplied by height cube. From what we got? We got from the corollary of this one. If I use this one, we know it is 1/3 multiplied by base multiplied by height cube for one rectangular cross section. B base height cube. Now this concept we will utilize. We can utilize here. This is one rectangular cross sections. Base is dx, height is y. So 1/3 base multiplied by height cube. We will use that expressions. So dix equal to 1/3 base height cube. Then this y equal to, we have to we have to put this y equal to in terms of x, that is this. Let me check here. This is here, correct? Y square equal to 9 by 4 x, y equal to 3 by 2 square root x. Yeah. Yes, 3 by 2 square root x. Then you do the integration, same value you will get. Yes. Now, the way we have solved the problem for coordinate system, to calculate the centroid, we have some composite area also. Similar fashions, we will decompose the material, the cross sections into different parts, part 1, 2, 3, 4 up to n. For every case, from the centroidal, at the center we will calculate Ix, Iy or Iz. Then we will use some parallel axis theorem concept. We can calculate dx, dy or z or r. Then we will use this expression that Ix equal to I centroidal I plus a d square for individual part. Then we can have all the summations. Once we will get all summations I and we know all value of a, then we can calculate kx, or it may be k equal to square root I by a, or radius of gyration. Radius of gyration, say I have this part. Okay, you have considered different components, different cross sections, but this k value or kappa value, radius of gyration will be single value for entire bodies. So that will be square root I or maybe summation I by summation a. That way we will use. Say I have 1, 2, 3, 4 different parts. 1, 2, 3, 4. This is the delta A. 1, 2, 3, 4 dx. 1, 2, 3, 4 dy. 1, 2, 3, 4 a dx square. Summation a dx square. 1, 2, 3, 4 summation a dy square. Ix centroid, this value, then this value, this is summation, this is the summation. Finally, I will be this Ix, this Ix bar plus summation a d square. Iy will be Iy bar plus summation a d square. And finally, single value of k will be square root I by a. Single value means entire one. K may be kx, ky, or maybe k theta. That is different. Okay. But this I where we will be using this expression, this a will be summation a and this I will be summation I. Square root will be the value of radius of gyrations. Now, till now what we have learned that we have taken some x-axis, first moment with respect to x-axis y dA, second moment with respect to x-axis itself, y multiplied by y dA, y square dA we got. Similarly, x square dA we got, r square dA we got. Because with respect to same axis, we have taken the moment twice. But it has been noticed that for unsymmetrical bending, unsymmetrical cross sections, okay, it is recommended to use that this moment of inertia, like not for the same axis twice. One is with respect to x-axis moment, other is with respect to y-axis moment. Say for example, I have cross sections is A. Take one moment with respect to x-axis, or second time you take another moment with respect to y-axis. So you will get xy, x with respect to x-axis, with respect to y-axis. When you are taking x-axis, you are getting y. With respect to y-axis, you are getting x. This is the distance, correct? Do the integration, and that will be similar way. We write x. Generally, some books write this way: ix square equal to y square dA, Iyy equal to x square dA, then Izz equal to square root z square dA. Here it is Ixy, integration xy dA, integration xy dA, Ixy. So this is the format. So what we can notice that one is with respect to x, other is with respect to y. We call the new name for this. We call product of inertia. Product of two distance, both x and y. Okay. Now you can consider this one. This is the symmetry axis. With respect to this is symmetric, this one and this one. So IXY equal to integration x y dy. I should write better way x y dA. Now if this is the symmetry axis, I got one point here, I got another point here. Complementary. Why complementary? X is same. But in this case y is positive, but same distance from here, it is y is negative. That means whatever integration value you will get for this point, positive value, same negative value will get here. Initially what was there? It was y square dA, x square dA. So always these are positive. But here it is xy dA. Now if x is positive, y is positive here, x is same, this point and this point, y is positive, here y is negative. Then this area multiplied by xy will be same of this area multiplied by xy. That means when you are doing integration, that is nothing but the summation of the entire section due to the symmetry, integration integration xy dA, that is IXY, product of inertia will be 0. Why it will be 0? There will be some sort of area, there will be some reflection of the area due to the symmetry. Say same x value, y one is positive, other is negative, they will be cancelled out. So finally product of inertia will be symmetric section will be 0. Symmetry section, product of inertia will be 0. Have you understood this point or should I explain once again? Let me know. Should I explain once again or you can understand? Hello?
Yes, sir. Once again.
Okay. Yes, sure. Actually, we have one symmetry axis here. So if this is the symmetry axis, say I have considered one area here. There will be some complementary area in other side. For all cases, okay. Say this is distance A. So this distance will be minus A. So this is say B. Here also it is B. Now x, y, dA. dA is same. Okay. So now it is A multiplied by B. Here it is A multiplied by B. Here it is B multiplied by minus A. So it is AB, it is minus AB multiplied by say A. Here some value say A. So this summation, integration is nothing but the summation. So once you will do this summation, finally it will be 0. X is one, it is multiplication of x and y distance. So for due to the symmetry, you will get some area corresponding that complementary area in other side from the symmetry with the same distance. One is positive distance, other is negative distance. Say here A is positive, A is negative. So when you will add up everything, this value will be 0. So product of inertia for the symmetric section will be 0. Have you understood now?
Yes, sir.
Okay. So that's why symmetry sections it is 0, but unsymmetric sections like this is one section. This is unsymmetric section, Z section. Sometimes L section. This is smaller value. This is higher value. Okay. So this will produce product of inertia. Okay. This will produce a product of inertia. Okay. Now in product of inertia also we can transfer the axis. So IXY. So this is the centroidal and this is the other one. We want to transfer using parallel axis theorem. This is dx, this is dy, this is d. This is y0, this is x0, this is dA. Now with respect to IXY, with respect to this coordinate, okay. So this is x, this is y multiplied by dA. So x is x0 plus dy, y is y0 plus dx. Now simply multiply this, okay, multiply this. So this is nothing but IXY, centroid, or IXY CG, and this is 0 by definition. This is also by definition 0. So this is A, and this is the distance. So IXY will be getting IXY bar, you can write, or IXY CG also you can write, plus dx dy multiplied by A, or dx dy multiplied by A. Actually what happened, at that time it was d square or dx square or dy square. Now the dx dy they have split it into two. One is dx and dy. Initially it was same. So y square dA, x square dA, z square dA. Now it is xy dA. Okay, now it is xy dA. This is done. So this is the relationship. Now this is last one for today. We called rotation of axis. What we have learned till now, we have transferred the axis using parallel axis theory. Now we want to rotate the axis. Let me show you. Say this is the initial configuration. This is the initial configuration. Then I want to rotate this whole body. I want to, sorry, this is the initial coordinate, and we have calculated, say, Ix, Iy. What we have calculated? Ix, Iy, and Ixy. Now what we want to do, instead of all these three, we are looking for some plane, or maybe with some rotation, initially like this, maybe initially like this, with some rotation, we want, let's IXY is 0 with, for that particular case, with some rotations, and we have only Ix or I max or I minimum. That is our target. We have some imaginary rotations we are considering, for which we can get, there should not be any product of inertia. Only it is having I. I means in that case it will be I maximum or I minimum. I will show you. Now if I rotate this by using some theta degree, rotate this, you consider this is x, this is y, this is x prime, this is y prime, and rotation is theta. Then this distance will be, this is the x, this is x, and this is y. This is x and this is y. If you rotate like this, then this vertical distance will be x sine theta. And for this x, it will be x sine theta, and this will be x cosine theta. For this y, this will be y sine theta, this will be y cosine theta. Next page I will show you. This is x, y, x bar, x prime, y prime. This is theta. So now this is y prime, x prime, x and y. This is x and y. Now for this rotation, what we are looking for, we have to calculate the distance. We want to calculate the distance. So let me show you this way. Extend this. From this, extend this. And this is 90 degree. Okay. This is 90 degree. Now very carefully, if you see y value, this is y. This is y, and take perpendicular distance like this. This is 90 degree. If this is y and this is theta, then this distance will be y sin theta. Have you understood this one? If this is y, this is theta, then this distance will be y sin theta. Got it? Yes or no?
Yes, sir.
Okay. This is y sin theta. Next, for if this is x, if this is x and this is x prime, so and extend this, we can extend this. This is theta. This is also theta. This is also theta. If this is x, this is theta. Here it is theta. Then this distance will be x cosine theta. This distance is x cosine theta. X, understood? If this is x, this is theta, this is x cosine theta. X prime will be x cosine theta plus y sin theta. Have you understood this?
Yes, sir.
This to this distance will be y
Yes.
sin theta plus x cosine theta. We got that point. Now for y, we have to come for y. So what we got here, we got this to this distance is x, then this is the theta, then this will be x sin theta. If it is x, this distance will be x sin theta. Okay, and if this is the y, and we got this is the theta, this is the 90 degree, this theta means this theta, then this distance will be y cosine theta. This is y, this will be y cosine theta. Then y prime will be y cosine theta minus x sin theta. Have you understood this? X prime and y prime. X prime is x cosine theta plus y sin theta. Y prime equal to y cosine theta minus x sin theta. Should I explain once again? Okay.
Sir, y cos theta plus x sin theta.
No, I'll tell you. This is the okay. Color I'll change. Good question you have asked. Actually, this was y up to this. Okay. That's why up to this it is y cosine theta. And this is x sin theta. And y bar is this. This is y prime. Only this. This is total distance minus this distance. Y cosine theta minus x sin theta. Have you got this now?
Okay, sir. Yes,
Okay.
sir.
I'll show you another example. I think I have posted there. It will be better. Wait. Okay. I have explained these things. Okay, these rotations. Another rotation also. Yes, here from there you will understand. Yes, I have posted this for you also. Okay, so it was, this is the y prime, this is the x prime, this is y sin theta, y x cosine theta, y cosine theta, x sin theta, and this is the relationship y prime x prime. Now with this one rotated one, so we have ixx prime, iyy prime. So what is ixx prime? Integration y prime square dA, here integration x prime square dA. Now nothing, just you have to replace this and you have to do the calculations. I'll show you elaborate one. I have shown you. Okay, so we have used these expressions. Let me take a different color. Then this square iy, then I want to split it. Then if I ask you in your exam, don't have any step jump. I'm just working on that. Working on that. Finally, I am getting these expressions for IY prime, IX prime. For IY prime, expand this. Similarly, you will be getting this expression. Now, for just a minute, I have just repeated for you. Now, this one, IX prime, Y prime. This is X prime, this is Y prime. You work on, you will be getting this expression. So, three expression you will get IX X prime, IYY prime, IXY prime. Now, once you will get these expressions, let me show you better. Yes, here it is better to show. Yes. So, one, this is IX this, and this is Y, and this is product of inertia. Now, if you take this, and this to get the maximum value, what you can do? I x prime or I y prime, do the derivative to get the maximum and minimum value. Then you will be getting tan 2 theta equal to minus ixy by ixx minus iyyy. I have written ixx iyyy for better understanding. Okay. Then this is maximum value or minimum value. Ix maximum value or minimum value. Now, if you look into the expression for ix prime, iyy prime, and put this ixx prime minus ix x plus iy by 2, this one, this square, plus I xy x prime y prime square equal to this will be sin square 2 theta cosine square 2 theta, here sin square 2 theta cosine square 2 theta. So the theta term will be vanished, it will not be there. Okay. So finally you will be getting this way, x minus y square plus y square equal to r square, where center it is the expression of the circle. Center is h0. What is the h? Ix plus iy by 2. This is the center. This is the h value, 0. What is the radius? Square root ix minus iy whole square plus ix square whole square. What is the Imax? Center plus radius. I mean center minus radius. So what we can do? We can draw one circle called mode circle. How will draw? This is I value, sorry, Ix or Iy value. This is Ixy value. So one point say Ix plus Ixy. Other point is say Iy minus Ixy minus Ixy. Then you add these 2 points. You will get one center. Draw the circle. If you draw the circle, you will get, sorry, it may not be middle. You will get here, it is I minimum. Here I maximum, this point, maximum. Okay. And you will get some radius. This is the radius. And this is the center. And you can write here, this is Ix, this is the Ix, this is the Iy, this is Ixy, this is Imax, this is Imin. What is the center? Center is Imax, Ixx plus Iyy by 2. This is the center. Radius, square root Ixx minus Iy by 2 whole square plus Ixy whole square, that is square root. What is 2 theta here? 2 theta. That tan 2 theta from the geometry also, circle also you can write minus Ixy by Ix minus Iy by 2. Let me see. 2 Ix, wait, one expression, let me cross verify it. more circle I have drawn, then I can come back here, I guess. Yeah. So what I have shown from there, you can understand better way. This expression already you have did this one, then this expressions. Then one thing you can check this ix prime plus iy prime equal to ix plus iy. But whatever I have changed, but summation will be same, equal to iz. So iz will be same. Okay. So 2 I missed. Yes, I was looking for this 2. Let me check whatever I have uploaded, whether 2 is missing or not. Some 2, yes, 2 is missing here. That's why I was looking for some mistake. Let me check. First one, this expression 10, 2, 5, 10. Yes, here it is 2 is there. Yes, it is correct. So I have to correct here. 2 is missing. This I'll do that. I'll update this. Okay, don't worry. Let me come back here. So this is the expression we got using the derivatives here, and you can see this is the appendix in your book. This chapter is available in appendix. Let me check which appendix. Area moment of inertia you will get from Miriam Craig. The appendix sections. Article A. Okay. Appendix A. Okay. There you can get more information. So finally, this is the center. This is the radius. Okay. So if this is the center and this is the radius, so center plus radius is maximum, center minus radius will be the minimum value, and this is the 2 theta. You have to recall this is 2 theta. In reality, it was theta. In motorcycle, it becomes 2 theta. Why? Because when you have derived the expressions, you have this cosine 2 theta, sine 2 theta term. We have eliminated this 2 theta by taking this square. That's why that cosine theta mode circle in reality it is theta. Here it has been shown ix. This is the ix, ixy. This is the imax. This is the iy. This is the imin. This is the here it is shown alpha. Twice alpha becomes reality alpha. Okay, that's all. Now we can solve one problem. Determine the product of inertia about x and y axis of the area under the parabola. So this is the parabola given. Now it is passing through point A, comma B. So you can calculate the value of k value. Now maybe you have considered one small strip dA equal to dx multiplied by dy, and distance one is x, another is y. Then elemental dixy equal to xy dx multiplied by dy. 2 times integration we can do. 0 to b is y variations, and a variation is this value, x variation is this to this, and you put the value, you will be getting some solutions directly. Then other strip, maybe vertical strip we can take. In vertical strip, area is yda, dixy is 0, because this is symmetry, it is 0 with respect to symmetry. Then due to this axis, the distance we have to calculate x multiplied by y. X elemental is x, y elemental is y by 2. Then dA, do the integrations and you can get the solution. Similarly, horizontal strip also you can consider. Now, maybe one example given that we have to calculate the motorcycle I have shown where there is no product of inertia. It is called principal axis. Of inertia. We have to calculate the principal axis of inertia and also angle sections and corresponding maximum and minimum moment of inertia. Look, ix is moment of inertia, iyy or ixx, and ixy is product of inertia. So for this one, we can divide this into 2 parts, part 1 and part 2. For part 1, what is the product of inertia for part 1? IXY equal to IXY center plus 2 distance. You can calculate distance easily. Finally, you will be getting this value millimeter per 4. It is negative here. Likewise, for part 2, for this part 2, IXY also you can calculate, value will be this. So you got here IXY for 1, here it is IXY for part 2. Similar way what we can do for moment of inertia IXX, this is the centroid plus AD square. For this is the centroid plus AD square. For other part, this is the centroid plus AD square. This is the centroid plus AD square. So you will getting value. So you can calculate total I, total IX, total IY. Now you got total IX, total IY. Here you have calculated total IXY. Now you come this way, you know IXX, IYY, IXY, and this angle is alpha. So tan 2 alpha equal to what I told 2 IXY by IX minus IY. Here it is minus, or maybe IY you can put at the beginning. You just put the value, you will get twice alpha, then alpha you can calculate. Then for Imax, maximum value or minimum value, this is the center, then okay. What we can do, we can directly use, instead of this, what I told, we can use that expression that, what is the, you draw the mode circle. I do prefer draw mode circle, find center, say some A0, then radius is say some R, then sigma max will be A plus R, sigma minimum, sorry, not sigma, I minimum will be A minus R. In future, this I moment of inertia will be replaced by sigma stress. You supposed to have sigma x, you supposed to have sigma y, tau xy. So this sigma x will be Ix x, sigma y will be Iyy, analogous. Tau xy, Ixy will be shear stress, tau xy, and we will draw the mode circle accordingly. Not now, in third semesters. Now there are some specific problems I can discuss, that this arc segment, this is the centroid. This one, this is the table you can see in the book for your reference. This is the area moment of inertia. For circular one, we can calculate. For this type of figures, we can calculate area moment of inertia. This figure, these are the things we can take from your books. You can see. So what you can expect in NSEM 1 compulsory questions. One compulsory questions I will ask from moment of inertia MI. This will be one compulsory sections 6.1, 6.2, 6.3 problem sheet I have given. Try at your own. Next day, whatever you are facing the issue, I will solve that. Next week, dynamics will be start. I am very shortage of time. I have to finish the syllabus. So it is recommended for you. This is some other example also. Okay, that you have to theory portion I have solved. I have given everything exclusively discussed. Your task is you have to start solving the problems from the problem sheets, which I have already given. Any questions do you have? We can discuss before taking attendance. Any questions you want to ask?
No.
Okay, fine. See, the issue is, I'll tell you. Let me stop sharing the screen. Okay. Let me. So issue is, students are listening to the class. Everything is fine, but they never spend time for exercise. That's why in your midterm exams, many students have not performed well. Okay. So 22 2, and many students their score is will be they will get less than 10 out of 30. Many students. Okay, let me take attendance. Aerospace 25 absent, 26.
Yes, sir.
Okay, 27,
Yes, sir.
28,
Present, sir.
29,
Present, sir.
30,
Present, sir.
77 civil. Okay, 79,
Present,
80,
sir.
Present, sir.
81,
Present, sir.
82,
Present, sir.
83,
Present, sir.
84,
Present, sir.
85,
Present, sir.
86,
Present, sir.
87,
Present, sir.
88 absent, 89,
Present, sir.
90,
Present, sir.
okay, 91 absent, 92 absent, 93 absent, 94 absent, 95,
Present, sir.
okay, CST 58 absent, 59 absent, 60,
Present, sir.
okay, 61,
Present, sir.
62,
Present, sir.
okay, 63 absent, 64,
Present, sir.
65, 65 absent, 66 absent, 67 absent, 68,
Present, sir.
69,
Present, sir.
yeah, 79, sorry, 1 minute, 70, yeah, 70, then
Present, sir.
70 present, yeah, electrical 49,
Present, sir.
50,
Yes, sir.
51,
Present, sir.
52,
Present,
50,
sir.
53, 54 present, 55
Yes, sir.
present, 56 absent, 57 present, 58 present, 59 present. Just a minute. Then electronics 35 present, 36 absent, 37 present, 38 present, 39 present. Okay, 40 present, then 41 absent, then 42 absent, then IT 53 absent, 54 present, 56 present, 57 present, 58, 59, 60 present,
Yes,
61
sir.
present. Yeah, 61 present, 62 present, 63 present, 64 present. Then mechanical 49 absent, 50 present, 51 absent, 52 present, 53 present, 54 present, 55, 56 present, 57 present, 58 present, 59 present. Okay, 60 absent. Then B 25 present, 26 present, 27 present, 28 present, 29 present, 30 absent. Then mining 25 present, 26, 27, 28, 29, 30 present. Once again, those who are absent, let me tell once again, aerospace 25 absent, then civil 88 absent, then
Sir, me
90
present.
civil
88 present, sir.
88, just a minute, 88 present.
So there was actually.
Yeah. Civil 91 absent, then 94 absent, CST 58 absent, 59 absent, then CST 65 absent, 66 absent, 67 absent, then
Present, sir.
roll number once again,
CSB 67.
67. Just a
Sir,
minute.
CSB
So
65 also present.
65 present, okay, 65 present, 66 absent, okay. Then electrical 56 absent. Then electronics 36 absent. Then electronics 42 absent. IT 53 absent. Then mechanical at 51 absent. Then mechanical 60 absent. That's all. Do you have any specific questions you want to ask? Attendance is over.
Sir, my class representative might have informed you that about
Yeah.
the midsem paper.
No, not getting. Once again.
Sir, I today accidentally unsubmitted my midsem paper.
Okay. See that I have noticed it. Don't worry. So whatever you have submitted before, that copy I have. Okay, no problem.
Okay,
Yeah,
okay, sir.
it's fine. I have the old copy. I'll check that one. Don't worry. Huh?
Okay, sir.
Any other queries you want to ask? Okay, I will tell you what is happening. You might be listening to the class, everything is okay, but you are not practicing. That's why when I'm changing the data in exam, you are not able to perform well, which I have noticed in your midterm, and also I have not gone through details, and also
Sir,
classes.
if we are not able to get the final correct answer, then how much marks is cut? Like
See, it
last year,
depends. See,
calculation error.
if I find now you are honest, you have taken the honest attempt, you have reached to the end, but answer is not matching. I can give around say 70% marks. I can give if all steps are fine. There is some silly mistake. But say for example, one problem I have given in CG, I have introduced one circular hole. Somebody is not consider the circular hole, then I will give 0. Understood? Mistake means in what respect it is mistake, that is also important. So say in book it is 40 kg. I have given 41 kg. You did mistake. You have used 40 kg. I will give 0. Understood? I am not talking about that mistake. I am talking about the mistake. You have used some tan theta equal to some value minus some value. But unfortunately in calculation you did some mistake. That is different. Okay. Those case maximum 70% marks I can give if you reach to the end of the solutions. Otherwise you can expect it will be in between. If you do some mistake at the beginning itself, maybe 30% 40% marks I can give. Okay, but if I find that somebody copies, then I will give 0. That is sure. Means I have not
Sir,
asked one data, but if I found some data which I have not asked, then definitely I'll give 0. Yeah, tell me.
sir, I forgot to rename the file, sir.
Don't worry. Whenever you upload the file, it is in your name. Okay, I can rearrange. Some extra effort I have to give, but don't worry, I'll do that. Okay.
Okay.
Next time, be careful. It will save my time. Okay.
Hello,
Once
sir.
again, yeah.
Yes,
Tell me.
sir. If any problem is a solution answer is wrong and FBD is correct, so what marks will be given?
Okay. FBD is correct. Answer is wrong. For FBD around 2 marks for FBD out of 10.
Okay, sir.
Okay. Say somebody has correctly given FBD 2 marks. Then half of the solution somebody did. Okay. But answer is not correct. Then maybe I can give instead of 5, I can give 4 marks. If I found the student approach is honest, then I can give maximum 50% marks in that case, even if you are not reached to the final answer. But somebody goes to the final answer up to that, but answer is wrong. Some mistake he did due to the time issue, then I can give 70% marks. Understood? But
Okay,
if
sir.
I found something that some data I have changed, you have used some old data, then if I wish, I can give 0. That also depends. Okay, because at the end, your score is important for you. That I'll check it. Understood? But I'm surprised. Many of students perform very bad. Understood? Some students they performed extremely well, but major students they are not able to answer all questions. Maybe some students answer only 2 questions. I will tell you. Idea was we have made the question such that only some students who has tried at least 2 times to solve each and every problem, that student will be able to answer 3 problems. Or else you will have some shortage of time. Somebody is starting, say, trying for the first time, that student can maximum solve only 1 problem and may not be answer, may not be correct. So practice is required. At least or all the problems should be done at your own. Don't copy from your friend. For your understanding, you can copy, no issue. For your understanding, you can take help from your friend. But in exam, each question data will be changed, and we are looking for, if we find any old data from the problem sheet, then I will give 0. That is our one way to save time in this pandemic, because in this pandemic, different ways students are trying to get the marks, and we are here to deduct the marks. So none of the problems will be with the same data. So I can identify that easily, that you have used some old data from. So that means you are not solving at your own. You are maybe you have solved that one at the time of assignment, but now you are copying during the exam. That's why you are getting the old data. So those case, it will be better for us as an instructor to check the answer script. Some time will be saved for me, and you will be loser. So at least 2 times you have to solve. Otherwise, in exam, see, it is very tight schedule, because we know actually your instructor, we have the information. So somebody can do one problem number 1, your friend can do problem number 4, then you can interchange. So we have adjusted the question such a way that even it is open book test, you will not able to perform. No, time will not get time. It is very tight schedule exam. To get 30 out of 30, you from the beginning itself, you have to start writing. At the end, at 45 minutes, you have to write at your own. Then only you will able to solve the problems. Okay, you can check with your other friends also, other department, like other group, basically 5. Your group 5, 6, 7, 8. Those students also, they are getting all same questions. Okay, so we as a faculty, we have some one serious meeting, that students are adopting this. These are the sources they are utilizing. Even if we give any questions outside from the book, any book, whatever book we will give the questions, students can easily can get the answer. Okay, within that 45 minutes. So what is the solutions? So we can bring new, we can give the new problems from the new different books, but we have to change the data. Once again, we can utilize the problem sheet, but we have, say, in frame problem, we have introduced some extra weight, because the students who have solved that problem before, at his own or at her own, he can solve that. What else you cannot do? So same procedure will be adopted in the final exam. And if you are not enhancing yourself, then many students will get supply. Okay, many students are score will be 0 for midterm. In midterm, many students score will be 0. That I can roughly I can tell you. Not many, at least 5 to 10 students will score 0 out of 30 in midterm. So if you are not changing your attitude in final exam, you will suffer. Definitely, you will get supply. Okay, so we are no way we are giving direct questions without changing data, because we cannot rely on this system. If it is offline exam, then we supposed not to change the data, so that at least student can get some benefit for that. But nowadays, due to this online system, all benefit students are getting. Entire world, internet system with the students. So what to do? We have nothing to do other than to change the data. So sometimes you might be this one. Some students are suffering. I understood that one. Okay, but we cannot do anything. You believe me, if I give all the problems without changing data, many students supposed to get around 20, I think 80% students supposed to get 28, 29. But that should not be there, correct? So without knowing the subject, no one can get grade 10 from applied mechanics. That I can assure. Okay, this department is not that much of good for the students. Yes, two person will be evaluated with the good marks. That's all. See, now only one option we have. First of all, there will be, listen carefully, there will be one question, compulsory questions from moment of inertia. I have provided 22 problems. One problem will be there in the final exam for the moment of inertia. Second one, the remaining dynamics, I have very less time. I have to cover the syllabus with a very short time. But dynamics maybe four problems we can set. Statics, from statics maybe two, three questions we can set. And we'll set such that you have to answer for from the statics as well as from the dynamics. You cannot use such that only dynamics and you will be able to answer all. You will not get that opportunity. Or only static, no dynamics, you will not get that opportunity. You have to learn both. Okay. And you can recall, I have given three assignments. Problem sheet 1, 2, 3. Equilibrium, friction, and thrust problem. Idea was, if my students are serious for these three assignments and they are doing their own to solve these 30 problems, then in this midterm you are supposed to get at least 25, because there are three problems from those three problem sheets. Problems are new, but concept is same. But what you did by mistake, you thought that let's two or three students can solve the problem and we can copy those things and will put as the assignment. And you did that. That's why midterm you thought similar way. So that questions was twisted. Midterm was class test was twisted. Midterm was twisted, and definitely NSM also will be twisted. Now question is whether some students, major students, will get supply or not. That is the big concern for me now. Let me check with your response in dynamics portions, and already I have given this the study material. This is not assignment. This momentum inertia is a study material. You solve at your own. Ask me next day. Be serious. Otherwise, you will suffer. I cannot do anything. Okay. Say for example, you score in 10 plus 2 standard maybe 80 or 90 percent or 98%. Say now if I give this mechanics only 41, then your CGPA will be drastically reduced. And if it is 41, you cannot change your department also, because if somebody want to change the department, for that one your semester 1 and 2 good marks is essential. Okay. So try to be little bit serious about this subject. Okay. So that at least score around 60, 70, 80, 90. That target you can fix. Or else no. My intuition says around 20 students will get supply if this way you continue. And if you are getting supply in a single subject, then most of the companies will not allow to appear in the campusing. That information I have shared you before also. Okay, don't take it very casually. Be serious, and I am trying my best to give the information, to pass you information, to explain the things. But your effort is also required. Okay, your effort. See, NSEM means only 50 marks. Try to understand. 50 marks is already gone. Not 50 marks. At least I'll tell you, mid-sem 50 marks is over. Whatever you performed, you will get that marks. Class test, one test I have taken, 10 marks is gone. Then I have assignment, attendance, if it is 10 marks, or maybe I have to think something else, such that that will go benefit to the students. I have to do some other measurement. Maybe, I'm not sure. Okay. See, say for example, the class test, midterm, some students will score 0. I cannot do anything. Then the students will appear for remaining 70 marks. Out of 70 marks, to qualify, you have to get 40 marks. And if you class test you got score 0, then if I give you there 10 marks, then out of 50, you have to score 30 marks to qualify. That means internal out of 50, 30 midterm, class test, assignment. If you score 10, then remaining 50 will be rent same. So 10 if you got here, then out of 50 you have to score 30. Then only you will qualify, pass marks 40. Have you understood the difficulty now? If your midterm score is 0, class test score is 0, then I can give you maximum 10 marks. Out of 50, you already scored 10 marks. Then end sem will be 50 marks. To get 40 total, you have to score 30 out of 50, which is quite impossible. 60% marks you will not get if your midterm is 0, class test is 0. I think you are doing something very seriously wrong approach you have adopted. Be careful, okay? If you are facing issue during the class, you ask me. I am here 2, 3, 4 times. I can explain that. But to ask me any questions, you have to try at your own, because once you will ask questions, I will understand whether you have learned the subject, whether you have practiced something or not. That's why major students are keeping quiet. And finally, your score will be either supply or less than 50. Your CGPA will be very bad in that case. Be careful, okay? Anyway, today is already almost 5:45. See you on the next day. So 6.1, 2 and 3, you try at your own. Come with the difficulties. You are not able to solve the problems. I will give you the hints. Next week, next Tuesday onwards, I will start dynamics. For dynamics, I have only 8 days to take the class. I have to cover the syllabus first. Okay, I am very doubtful whether I will be able to take any class test in near future or not. Okay, because time is very short. Anyway, so all the best, and my suggestion is be serious and complete this 6.1, 2 and 3 by next week, so that we can discuss whatever the problems you are facing to solve. That's all. Okay guys, bye.
Thank you, sir.
Okay, bye,
Thank
bye,
you,
bye,
sir.
bye,
Thank you,
bye,
sir.
bye.
Thank you, sir.
Thank you, sir.